Good morning to everybody. So, in this lecture, I will discuss a special topic which is known as sorting. So, sorting is basically, as we know, that to rearrange something. Okay. So, from a stack of books, we sort that which are the important one. From the stack of documents, we sort which are the important ones. So, like that, from the stack of clothes we short that whether you will wear those clothes in future or not. So all these methods are sorting, so these are related to the practical life. But here in case of C programming we will do sorting algorithm. There are some methods of sorting, so that's those are known as algorithm. So those sorting algorithm will be useful for data handling in case of computer. Okay. So let's discuss this sorting algorithm. This sorting algorithm will be discussed into two parts of this. So today is the first part, and after that I will discuss the second part also. So without further delay, let's go on discussing the sorting. Now sorting, the word sentence is written that bringing order to the world. So to make something in a particular order, so we need to do the sorting methods. Now the lecture outlines are this. So there are different types of sorting methods. Now one type is that iterative sorting algorithm. So based on the iterations, we will do some sorting algorithm. Those are named as selection sort, bubble sort, insertion sort. So these three will be discussed in this lecture. And next one is the recursive sorting algorithm, which is two types of merge sort and quick sort. So this will be discussed in the next lecture. And some other points that radix sort, which is non-comparison based. So these tools are comparison based, and radix sort is non-comparison based. So in place of short comparison of sorting algorithms, we will discuss also. So here we consider the sorting of data in ascending order. That means from smaller to the higher value. Right. Now, why to start sorting? So when input is sorted, many problems become easy, such as when you go for searching, when you try to find minimum value, when you try to the maximum value. Sometimes we try to find the kth smallest value. So all this can be done or can become much easier when the data is sorted. So there are different types of varieties of sorting algorithm. Those are comparison and non-comparison based, iterative, recursive, divide and conquer rule is there also. Base sorts and average case bound and randomized algorithm also there. So we'll discuss those are important with respect to our mm, undergraduate curriculum. Now the application of sorting. So we can apply the sorting algorithm in different areas such as uniqueness testing. So whether something is unique or not, and deleting duplicates. It's the most important parts whenever we're dealing with our computer or mobile phones. There are a lot of duplicate files are present in our computers and mobile phones. So the sorting methods is useful for that case. Prioritizing event. So when some events we need to prioritize, in that case also we apply sorting. Frequency counting, you will come to this point later on after your at your curriculum. Now reconstructing the original order, so that is also that the application of sorting. Now finding a target pair and efficient searching is also an important aspects of sorting. Now we discuss about selection sort. Now the steps or the algorithm of this selection sort is that find the largest item x in a range of 0 to n minus 1. So we have say five elements. So the five elements array. So in the array, the array will be start from 0 and it will go to 4. So in this array, so we will find, so that is n is 5, so it will start from 0 to n minus 1, that is 0 to 4. So within this 0 to 4 range we find the largest value. Okay, so that is the first thing. And after that, the swap x with n minus 1th item. Okay, so when we find, say suppose we find at say second position, so at two positions we find the largest value, so then we will swap that 2 with the fourth position. So we will just swapping, so value of 2 will come at the fourth position and value of 4 positions will come at second positions. So that is the second step. And we reduce n by 1 and go to step 1. So again the n again there will be this loop will go on, and in that case that n will be 4. So it will start from 0 to 3, and when it find it place at the third positions, and again it will go for 3 and it will go on continuing. Coming to an example, so this is our example. So the example is there are five numbers 29, 10, 14, 37, 13. So on the first line, as I mentioned, that find the largest element x. So on the first line we find after executing that first statement, we find that 37 is bigger. So what is the next step? So we replace 13 with 37, and so this replacement occurs, and after that one iteration is going on. So in that case we find 29, so 29 will come at these positions. Okay, and 13 will go to the 29th position. After that another iteration will go on, so then there is 14, so there is no change in that. Again iteration going on, then 13 will come in this position of 10 and 10 will come in the position of 13. So this array is become now sorted. Okay, so that is our fundamental logic of this selection sort. So we select the highest number first, then it will placed at the rightmost position or the far end position of the array. Okay, so again we decrease the value of the n and we will do the same things, and it will continue till the array is not sorted. Okay, now there is the implementation. So there is a function selection sort is written int a, that is the array will fetch, and int n, what is the value of n. Now for I equals to n minus 1, that means for int I equals to n minus 1, that is for 5, I equals to 5, I greater than equals to 1, I minus minus. So it will start from the right side. So it will start from the right side. Now int max id, so max idx, so max idx is the I, so that is the 4. So initially in our case, so max idx equals to 4. Okay, and sorry, max idx is equals to 4. Now for int j equals to 0, j less than I, j less than 4, j plus plus. So if ij equal greater than equals to a max idx, then max idx equals to j. Okay, so max idx, so only id, so only the position is been checked. Okay, position is been swapping. Okay, So max idx, say suppose in this case, so max idx will be got at 37, that is 3. Okay, so max idx equals to 3. So 3, so j equals to 3, so therefore max idx will become j. So then the swap ai equals to aid max. So there is some swapping function will be there. So using that swapping function we can swap this two values. Okay, so that is the our selection sort. So try to implement the selection sort using that selection sort function, swap functions, and main functions obviously. Try to implement and take some values and try to sort that. Okay, so not take a higher amount of values, say suppose 6 or 7 values. Okay, now number of times it is executed. So the first line will be executed for n minus 1, the second line will be executed for n minus 1, the third line, this line and this line will be executed, so n into n minus 1 by 2 times, and this line will be executed n minus 1. So total is that c1 into n minus 1. So n minus 1 is common, so we can consider that c1 is a cost statement c1. So n minus 1 plus c2 into n into n minus 1 by 2. So it will become that order of n square. So it will become order of n square. So the system complexity is the order of n square. Clear? So up to this it is clear to you, hopefully. So next we will move on to that another sorting algorithm which is known as Bubbleshot. Okay, in case of Bubbleshot, we have to follow these steps. So given an array of n items, so we have an n items array, compare pair of adjacent items. So there is this is a different technique. So we want to compare the pair of adjacent items, swap if items are out of order. So if those are out of order, so then swap with each other, repeat until the end of the array. The largest item will be at the last position. So reduce n by 1 and go to step 1. Okay, and analogy is that the large item is like bubble that floats to the end of the array. Large item is like a bubble that floats to the end of the array. So in selection sort, that we select the large item and we push to the position of at the end of the array. But in case of Bubbleshot, it is floating around this. So we come to the examples and then we can easily understand. Now these are our problem. Okay. Now what it is going done? Pass 1, pass 2. So this is the pass 1. So in pass 1 we find that 29 and 10 is out of order. So we swap. Okay. Now we compare 29 and 14 is out of order. So we swap. Okay. Now 29 and 37 is out of not out of order. So it is not changed. There is no change of the position of the 29 and 37. Now we compare 37 and 13, it is out of order. So 13 and 37 is changing their positions. Okay. Now come to the another pass where, so this is the our latest condition of our of the array. Now 10 and 14 it is in order, so there is no change in position. 14 and 29 it is in order, there is no change in the positions. 29 and 13 it is not in order, so there is a change in the position. So here the pass 2 ends. So similarly again there will be another pass. So the where 10 and 14 will not change in the position, 14 and 13 will change in their position. So this will be in pass 3, this 13 and 14 will change their position. So this will become an sorted array. So the if we check the uh, function of this, so here simply Bubbleshot we have mentioned one function. So int a, int n. Now for I equals to n minus 1, I greater than equals to 1, I minus minus, that is the same, it will start from last side. Now for int j equals to 1, j less than equals to I, j plus plus. Okay, so this is the compare of adjacent numbers and this is the swapping. Now if aj minus 1 greater than aj, so we go for swapping aj minus 1 greater than aj. So that means, so this aj minus 1, so aj minus 1 means j is 1, so it will aj equals to, so it is 0. So ej minus 1 is greater than aj, so 0 whether 0 is greater than 1, yes, so then we go for swap. Okay, so and for the next uh, for loop, then aj minus 1, so the aj minus 1 is become 29. So if we look at these things, so initially aj minus 1, this one, so for the first loop, so it is aj, so there will be swapping. Now aj minus 1 for the second time of the inner loop, so in that case it is greater than this value, so there is swapping. And for the inner loop, so this is not happening, so there is a change in the I, so there is a change in the I, so I become n minus earlier I was n minus 1, so I will go to that I minus minus, that is from 4 to 3. So then it will check that uh, from starting. Okay, so from starting it will go on checking that whether it is or not. So in this case it will find their things and it will swap again. Okay, so this is the our program or functions for Bubbleshot. So you can find this in earlier slides also. I have mentioned some website, so you can just copy and paste these things there and you can find that that how it is working or not. Now the analysis is outer loop, exactly n iterations, so there is no problem with that. Now inner loop have for when I equals to 0 it is n minus 1, when I equals to 1 it is n minus 2, for I equals to n minus 1 equals to 0. So the total number of iteration will be 0, 1, 2 up to n minus 1. So in that case n into n minus 1 by 2. So the total time is c into uh, n into n minus 1, c of n into n minus 1 by 2. So it will become O of n square, so order of n square. So Bubbleshot problem, the time complexity will be order of n square. Now Bubbleshot is efficiently with a order of n square time complexity inefficient. So however it has an interesting property that given the following array, how many times will the inner loop swap a pair of items? So this is already a sorted array. So if we go through the inner loop, there will be no swapping. The array is sorted, so can stop early. Okay, so we can implement these things whether that is the array is sorted or not. So here we have used that boolean functions, boolean variable. So the is sorted equals to true. So we consider that assume the sorted is true. So now for I equals to 0, I that the function if, sorry, there will be if these things then swap aj equals to this, and each sorted it will be false. Okay, so if this condition executed, if this condition satisfies, then uh, this will be executed, and it will return that the array is not sorted. Okay, so then only this for loop will run. So otherwise uh, the for loop will not run. Okay, so if is sorted return, so this flag remains the true after inner loop sorted. Okay, now the worst case input is in descending order. Running time remains the same, order of 1 square. The best case is the running time order of n. So already the input is in ascending order, so n times will run, the outer loop will run, the inner loop will not run. So that is the Bubbleshot modified versions. Okay, next we'll move on to that insertion sort. Now, insertion sort is similar to that game of cards. Okay, so start with one card in your hand, pick the next card and insert it into proper sorted order. Repeat previous step for all cards. So if you have an idea about cards playing, so you can understand easily that we generally organize in this manner. Okay, sorry, this will be another. So these blocks will be there. That is missed here. So first card we have taken. This 5 will be, this 10 will be there here, and there will be 5 here also. So this cards first card will be taken as 10 of spade, then second card is 5 of spade, so 10 of spade will be here and 5 of spade will be here, and the third card is king of spade, so 5 will be first, then 10 will be second, and king of spade is higher order, so it will be at third. So this is known as the insertion sort. So we'll pick one data and we'll insert into the particular positions of the array. Okay, so let's come to the illustration or the example. So start with this. So 14 and 13. So we compare 14 and 13. So 13 is greater than less than 14. So we just push 13 just beside 14. Now again we take one value 20. So 20 we know that it is in between 13 and 40. So we push that 20 at here, and 8 we have to check that whether where it will be its position. So we have find that it will be in the first position. So in the third iteration it will be at 8th position. Okay, so that is the insertion sort. So we insert at particular positions for that particular number. Now we come to the problem, that implementation. So void insertion sort int a and int n as usual. So here it is starting from I equals to 1 to n from left. So I plus plus so on. So int next equals to ai. So int next means that is ai means a of 1. So initially next value is a of 1. So we define it as int j. So for j equals to I minus 1. So for initially for j equals to 0. Okay, and j greater than 0 and of aj greater than next. So if j greater than 0 and aj greater than next, then aj plus 1 equals to aj. So aj plus 1 means that the next value. Aj plus 1 means this value. So aj plus 1 will be aj. Okay, so aj in aj plus 1 the aj value 29 will be there, and aj plus 1 will be become next. Okay, so already there is a next variable, and so this will do the thing. So from next, initially the next is the next is 29, and aj plus 1, aj equals to 10. So sorry, aj equals to 29. Now aj plus 1, so in place of 10 the 29 will be stored, and aj plus 1 equals to next, so aj plus 1 will become uh, next. Okay, so this is the step. So insert next to the correct location, right? Insertion sort analysis. So outer loop executes n minus 1 times, as we know that outer loop execute n minus 1 times. The number of times inner loop is executed depends on the input. Okay, so input will be that whatever the input will be given. So best case is the array is already sorted and aj is greater than next is always false, so no shifting of data is necessary. And the worst case is that array is reversely sorted and aj is greater than is always true, and insertion always occur at front. Okay, so therefore the best case time will be order of n, and the worst case time will be order of n square. Okay, so these are the analysis of this insertion sort. So today I will end up here with this insertion sort, and in the next lecture I will discuss about other sorting algorithm, which is recursive type. So uh, selection sort, bubble sort, and insertion sort, those are iterative type. So iteration is going on. So so as we know that for loop and is there. So these are iterative process. So these are known as the iterative sorting algorithm. Okay. Please share your views in the comment box.